Yeah, well, you know my theory on laundry. Welcome to the Hackaday podcast. My name is Mike Stish. I'm editor-in-chief of Hackaday.
Hi, I'm Elliot Williams. I'm managing editor of Hackaday.
This is episode 23, and it seems this week everything is broken. We'll be talking about broken Raspberry Pi, broken ADSB, broken Hackaday website, and broken automotive airbags. Oh, Elliot, the news this week is getting me down.
Why's that?
I'm very sad to hear that Maker Media has gone out of business.
Oh yeah, that is lousy news.
You know, we started to hear some hints of it like Thursday night, Friday morning last week, and I reached out to everyone I could think of at Make. Friday afternoon, Dale Doherty, who is the founder of Make, emailed me and said, I'll call you this afternoon, and called and talked to him for maybe 40 minutes, and he was very forthcoming with what's going on. Basically, they've just run out of money to operate the business, and they've gone into something called an ABC company, which is assignment for the benefit of creditors. This is an alternative to the Chapter 7 bankruptcy that is available to corporations in the state of California. And basically what happens is all the assets get transferred to this company, and then that person sells all the assets and tries to assign a fair amount of that sale value to the creditors of the company.
Any way you slice it, the news is sad, right? Because it's the total end of Make and the end of the Maker fairs with it.
Yeah, so it means, everyone that worked on the magazine, all employees have been laid off. So everyone that worked on the magazine, the website, and Maker Faire are out of work now. Make has a real place in my heart. I think that it was, coming of age right when I was getting into hacking. And I always share this story that I loved their television program on PBS, which I'm guessing you never really saw.
I didn't see that, yeah.
I maybe only had like 8 or 12 episodes, but I recorded them all on Myth TV over the air. I don't know if it was the first or second episodes. I think John Edgar Park was the host, and he showed you how to build your own HD TV antenna out of coat hangers and some wood. And I built one of those. My neighbors from across the street are like, how do you get such good TV signals? So I built a coat hanger antenna for them and put it in their attic too.
See, how awesome is that?
I know. So lots of happy memories. There's this website and the magazine that I think has a special place in a lot of people's hearts. And then the big Maker Fairs. Maker Faire Bay Area was the first one that at the height of it had, what was the number? About 175,000 people attending in a 3-day period.
They definitely tapped into a vein of kind of underserved, makery / hackery kind of something going on in the States at the time. That was also the same time that the first wave of US hacker spaces was growing up. And yeah, it was the zeitgeist, right? And they were fitting right in, and it was the perfect storm. And the magazine was great looking. It had awesome graphics. It had a broad variety of topics. It had something for everyone. And you didn't even mention Maker Media. The whole reason for it even existing is that it was originally a spin-off of O'Reilly, and they print books. And I'm the author of one of those books, and a bunch of people I know are the authors of those books, and I don't actually know yet what's going to happen to my book.
Yeah, I think most people don't know what's going to happen. There's all kinds of question marks that are going on right now. Now, Dale did say he is trying to put together plans to buy back the assets and get things rolling in a different way in either a B Corp or a nonprofit or just a different for-profit company. But he didn't have a lot of details on that, just that, he wants to find a way to keep going. Next time you're hanging out with friends, raise a glass and think about the good times of Make. I think they made the world a little bit better place, and yeah, sad news. Big news this weekend also was a bunch of flights canceled because ADSB. ADSB is a method of tracking where planes are. And a lot of them, or maybe all of them, I should say, use GPS to get that information. And what happened this weekend is the ADSB devices on certain planes were reporting that the GPS data was degraded to a point where it was no longer reliable. And this ended up causing, I'm confused on the number of flights that were canceled, but it seems that it was more than hundreds. It was possibly in the thousands. Take that with a grain of salt. I don't have a reliable source on that. In order to get these flights moving again, the FAA in the United States issued a blanket exception that you could fly with these not working as long as you stayed below 28,000 feet and you reported to flight control before you, or air traffic control before you departed. And that got things moving again, so it was only down for a short period of time. But looking at it this week, it seems that it was actually a specific piece of hardware, a Rockwell Collins GPS hardware. And the Collins spokeswoman said that they had identified a technical issue with one or more GPS products impacting availability connecting to the network. And the company said it determined the root cause and the resolution. The FAA came out and said, we are working to determine the cause of the problem, which may have resulted from a software update to the aircraft navigation systems. Oops.
Okay. That's creepy.
So, early word from the FAA is that they're investigating software update as the cause of this outage, which is bonkers.
That's not what you like to hear.
No, not at all. So I thought this was an interesting story. Go check it out. Adam did a pretty good job of explaining it. And I saw we even got referenced in a Forbes article as a reliable source on this one.
Woohoo!
Yay for Hackaday. And, speaking of being reliable, did you notice the site went down?
Speaking of software upgrades. Oh, man, that was the worst 3 hours.
Oh, I know, man. That totally sucked. So do you want to explain what happened?
Sure. So what happened to me is I get back up and I'm like, oh, I need to write something. I need to look up an article on Hackaday. I click. And what you see is this white page. It's white with black letters. Can you imagine? Creepy. And the one I was looking at actually had a nice piece of Joe's art at the top, but it was all monochrome and like so stylized and ugly. Oh, it was really horrible. We looked like every other cheesy tech blog who's too bored to switch out the default theme. It made me cringe.
I think I had a worse day than you did then, because I actually saw it when the site was completely down, which was for like 45 minutes. So I would like to shift blame away from us. We hire a hosting service
Always
through
shift
WordPress.
blame.
Yeah, through WordPress VIP so that this doesn't happen. And, they have a guarantee contractually to us for 99.9% uptime, which they missed on that day. Yeah, so the site was completely down for 45 minutes, along with dozens and dozens of other sites, and not small sites either.
BBC America was down. TechCrunch was down. I looked at the list shortly after, and I actually didn't feel so bad.
Yeah, so after 45 minutes, our hosting service got some things back up, but our custom theme that is gorgeously dark in allowing you to read white text on a black background was not available to us. And then the place where I screwed up, and I will take the blame on this one, is our front page was nothing. It had a comment section and nothing. It just said home on it. And so I switched around some things on the back end so that this default theme would show the most recent articles, and we were continuing to publish, so I wanted the new articles to be available, and that totally worked. What I didn't realize is, since our custom theme doesn't have a comment section on the front page or the blog page, when the default theme started and it did have a comment section, anybody leaving comments was blasting straight out to our RSS feed.
Yep.
Oops. So I'm very sorry for that. I don't know that there was any horrible profanity or otherwise awful stuff. I think it was just an annoyance that people were getting, 15 or to 30 RSS pushes in the course of like a half an hour until someone reported it and we immediately fixed it. So apologies for that. All in all, Hackaday was down for 45 minutes. We had the crappy theme for about another 2 hours and 15 minutes, and then it was back to business as usual. And again, I should probably talk about what caused it.
Sure.
We were, I would say, required to migrate to a new system by our host in April, a new system called VIP Go. And the party line from them on this was absolutely awful. It was like, you don't have to do anything. We've done all the work for you, which is a lie. There was so much stuff broke when we transitioned. We kind of got that under control. So what happened on Tuesday when this all went down is WordPress VIP had pushed an update to the software that runs their system, and it ended up hosing all of their containers, and then they had to reload all those containers. And there's something in their story where they say they had chosen a more robust fix that ended up taking a lot longer than they thought it would. It happens. Sorry about that, folks. Thank you for bearing with us through it all.
Yeah, so everything broken. That was the week that was. Let's turn this ship around and talk about some of the fantastic hacks we've seen over the week.
All right, so my first one is nothing short of incredible when you really dig into the details of this. It's entitled Vintage Speech Synthesizer Croons the Oldies. Dan Maloney wrote this about a project pulled off by Michael Wessel, where he took a piece of hardware called the Deck Talk and made it sing Xanadu. What's incredible to me is this sounds amazingly good. Did you listen to this on the video clip, Elliot?
What's incredible to me is that people used to listen to music like this.
I'm going to play a little bit of this for us.
TikTok version 2.0 is running.
A million lights are dancing, and there you are, a shooting star. An everlasting world, and here with me eternally. Xanadu, Xanadu, in Xanadu.
That sounds amazing, right?
Deck Talk can sing. That's awesome.
So I guess it's awesome to me because this hardware is so old. The chip inside of it is from 1984.
Right. This is the one that's the old voice of Stephen Hawking, right?
I didn't know that. Is it really?
He talked on this chip for like a decade. This was his voice.
Huh.
I mean, he wasn't singing Xanadu.
Oh, of course not. This is actually getting the commands as plain ASCII coming over a null modem cable. It's using phonemes, which are the basic building blocks of sound. And I've known about these. I've seen them implemented in 8-bit microcontrollers and that sort of thing. But I guess I just haven't looked at retro computers enough to realize how good it can sound if you're clever in the way you use them.
Like, it's better than a speak and spell, but you can tell it's from basically the same era. But it's got a great, I don't know, style's not the right word. Yeah, it's got a good feel to it, right?
Absolutely.
Well, my next hack is SOIC Byte, or is it SOIC Byte? A program debug connector for a SOIC test clip by Simon Merritt. And this is a sweet little project. It's actually just one really clever idea. Say you're building a project that has a microcontroller on it and you don't really have the firmware right the first time. Tell me if that's ever happened to you. And so what you need is an in-circuit programmer and some way to connect to this microcontroller and reprogram it on the fly, even on your developed PCB. And so the idea here is you need a debug connector. And debug connectors are always awkward. You can put a bunch of pads down and try to hold a pogo pin thing above them. Or you can put a bunch of pin headers, but those things are giant and they take up a lot of space. Or you can do something like what Simon Merritt did here in this hack, which is you design a specific footprint to clip into something you already have. And in this case, he took like a commodity SOIC chip test clip, and he built essentially an 8-pin layout with a bunch of drill holes that'll go through the board. And this thing fits perfectly into the drill holes, so it latches on tight and then makes the 8 connections to do its debugging with your microcontroller set up all in one. It's a great idea. It's something we should all be doing. And I'm going to have to try this design out myself 100%.
Yeah, this is so amazing. I did exactly what you were describing with the pogo pins when I did that coin-op badge last year. I took a AVR ISP, which is 6 pads. It's usually 2x3, but I put them in a 1x6 pattern on the edge of a circuit board. And then I bought pogo pins. I didn't buy the holders, the sleeves for them. I just bought the pins, and I hand soldered them to a piece of proto board. And then I had to soldered a ribbon cable onto that. And then I had to try and align it with the badge and keep it on the right pads during programming. And it just basically sucked. I could have done the exact same thing using this footprint. And I guess the only real difference is I would have had a couple pads on the other side of the board.
That's no problem at all, right? You're getting the board fabbed anyway. In fact, it
Well,
saves real estate. That's beautiful.
Aesthetically, if you're worried about one side of the board versus the other.
Ah, right. I see.
Yeah, but I didn't realize until just now that the holes that are drilled in there are for registering with the plastic fingers on the SOIC clip. This is even better than making your own jig. I mean, if you're going to do hundreds of something, yeah, go ahead and make your own jig. But if you're doing like 15 of something, this is perfect because it does the alignment, it does the connection. You can just buy the clip. You don't have to do anything manually.
You could see where Simon got the inspiration from this if you've ever seen Tag Connect, which is a similar idea. It's got little pins making connections, but also some holes drilled through the PCB to help it line up. That used to be my favorite way to put debug pins on. I think I like Simon's better even.
Yeah, I agree.
Another option, though, that I think is worth looking at if you're in this business of how am I going to get a bunch of pins off? And maybe it's better if you have more than 5 or 6 pins. If you want to put a lot of debugging pins on the end, is the good old-fashioned card edge connector. And a few years ago, somebody essentially rediscovered card edge connectors as a great debugging connector, and I think that's still a valid hack. If you can get one of those old like IDE 40 cables and saw that up, you've got a whole bunch of multiple pin card edge connectors at the ready to connect to any board, and all you have to do is make sure that the PCB is of the right width. I mean, that's what card edge connectors were developed for in the beginning. I really like Simon's because it gives you 8 pins, which is probably enough for debugging pretty much anything. Uses a commodity part, but the idea itself is so brilliant that I wouldn't be surprised if other people took this and designed their own footprints to match other test clips out there or whatever. Just the idea of making a footprint to match a cheap test clip is an absolute winner. So let's see what you all come up with.
All right, my next hack for today is another musical hack. And Elliot, I think we should play some sound from this one as well. This is the Dream Cube that Franco Molina built. It was covered in an article by Dan Maloney called Play to the Beat of This Robotic Drummer in a Box. And Franco is actually a performing musician, and he uses this on stage as the rhythm section for him. So you notice that is the hi-hat, the kick, and the snare. And it looks very much like this little box, which is about 1 foot by 1 foot by 1 foot, is actually playing those sounds because you see sticks moving and things are happening that are not necessarily electronic, but it is an electronic instrument. And that's what I really liked about this is his approach to it. Instead of just sensing when the sticks are hitting an object, it's actually using analog electronics to make the sounds themselves. So the kick has 2 piezos, one to one side and one to the other, and those are fed through an amplifier circuit and then a low pass filter. The snare is actually a mini Pringles can with a little piece of sheet metal over it, and it has an Electret microphone inside that is picking it up and then going through 2 amps. And then the hi-hat is a white noise circuit that is just going through a high pass filter. And I think the effects are spectacular.
Yeah, be careful now. The kick and the snare are both absolutely mechanical sounds, right? Like the kick is a little beater that goes back and forth and hits these piezos. And the snare's hitting on these Pringle cans with 2 little robot arms. How much more mechanical than that do you want?
All right, so that I will give...
My God, the one where we totally agree... The one where we totally agree, though, is the hi-hat white noise, because that's just a white noise generator. And anyway, the reason I'm being such a bastard and a stickler about this is because one of the coolest things I saw in this project was he had to do a whole bunch of trickery to get the timings right. Because when you write the Arduino code to fire off the hi-hat, because it's just a white noise generator, it goes on when you say on, because it flips a transistor and it goes on. But you want to hit that snare, you send a command to a servo that then moves an arm physically to hit the snare. That doesn't happen for a tenth of a second, a fifth of a second. I don't even know how far after the Arduino sends that command. And ditto the kick drum, because that little arm has to go until it hits one of the piezos or the other for any noise to be made. And so he had to do some really clever synchronizing to get the physical parts of this build, that is the kick and the snare, to work with the electronic part, which is the white noise hi-hat generator.
The snare drum, he's actually calibrating that like you would a 3D printer bed. You know, there are the metal beds that you put the probe onto the hot end and then you wait until it makes an electrical connection.
Oh, right.
He's doing that.
I didn't see that.
Yeah. He wraps a piece of metal around the stick and then he puts an alligator clip on it. And then he puts an alligator clip on a piece of metal on top of the snare. And then he can tell exactly how long it took from the time he sent the command for the servo to go until the two make a connection on top of the snare.
Oh, good Lord. I would have just listened to it and tweaked it till it sounded right.
I think we're both in love with this project for different reasons, and we're trying to tell each other why their reason is the poorer one. Yeah, so I also just like it to see, you know, there's the joke that if you're a musician these days, you just pull out your MacBook and plug it into the amp and then you're done. And it's kind of cool to see people that are like going this extra mile to build these showpieces that are also actually compelling auditorially.
Yeah, I mean, this guy's playing with the guitar. He needs a drummer. He can't just press play on a drum machine like it's 1992. Please. Correct me if I'm wrong. I think he has a foot pedal to change up between rhythm patterns on the thing because he's trying to play along live with the guitar, right? So he doesn't have a free hand to go over and say, you know, change up to pattern B. He has to hit it with a foot pedal. So there's actually, I think, a lot of thought in this. It's a super sweet little device. It's also tremendously simple on its face. Like, this is a good beginner's electronic project in a sense, but then it's also got so much nuance to it that it's a good beginner's electronics project for someone who really wants to learn something.
Yeah, I mean, you have to package it together in a way that it's not going to fall apart when you're taking it to the gig and it doesn't break on stage, which is what I'd be afraid of, both of those things. So thank you so much
This thing will break on
showing
stage.
us. Yeah, it will definitely break on stage. Thank you so much for showing us the insides and how you built it, Franco. I think that's really cool.
All right, my next hack is Doom on the NES, and it is a hack by the Raspberry. It's a phenomenal hack. You think you can't play Doom on the NES, and he goes to show you can. Well, kinda. It's got a lot of trickery involved to make it work. I love the video. He starts off with, you know, this is a stock NES, and with this cartridge, you could play Doom on any other stock NES. But the trick is, of course, in the cartridge. It's like nothing up my sleeve. Well, there's a Raspberry Pi in the cartridge. And this is actually similar to a hack we saw previously last year in May, reverse emulating NES Nintendoception by Tom Seven. So shout out to that project, which was at the time absolutely mind-blowing to me. This Doom takes it even a step further. So basically the gimmick is that the NES has a bunch of 8x8 pixel tiles in it, and it reads these off of a graphics ROM that's on every cartridge. And so the trick is, if you have, instead of a static ROM in there, you have, say, a Raspberry Pi, you can just feed it these images all the time, and you can feed it changing images as you're going along and use that to play essentially significantly more sophisticated and complicated video games, or show videos on the NES, or do whatever it is you want to do that you could never do before. You're just basically using the NES as a pixel receiver and displayer. So one of the things that was limiting the old hack, that is Tom Seven's Nintendoception, where he wedged a Raspberry Pi into a Nintendo slot, was the graphics throughput. It was just hard to get the data out fast enough. I'm not 100% sure, but it looks like the Raspberry's one is using a Cypress USB controller to do the data on the Raspberry Pi side to multiple pins out on the cartridge side. So that may be how he gets it to run smoothly. Because if you watch his video, it's actually significantly smoother and better looking, honestly, than even the original hack that it is building off of. I'm going to have to dig deeper into that, but I think that must be how he's getting more data to the graphics bus faster.
I am, pretty surprised at the quality of video that's coming out of it. I mean, it's grainy and there's some motion artifacts in when tiles probably shouldn't be moving, or you're seeing some differences in there. But there's a lot of data and a lot of, I guess, to your eye, usable resolution on there. And the other thing I thought of when I was looking at it is Doom doesn't look great played in DOSBox as it is, much less played on hardware like this. So it's an eye opener to see how successful this hack was.
I mean, this is another one where why would you do this? Because you can. Because it's the awesomest thing to do. There's no good reason to do this. Like, if you wanted to play Doom, just play Doom on the Raspberry Pi. Move on. But this is all about how far can I push the NES into ways that it wasn't meant to go. And if that's the point, mission accomplished.
Yeah, I think everybody gets to that point where they're like, I don't really want to play video games right now. I'm kind of bored of that. I don't really want to watch TV. What am I going to do? And you hope that the answer to that question is something crazy.
Well, let's talk more cartridges and video games. What you got?
Yeah, so the next one is really cool cartridge work. I think most of the Hackaday audience should be familiar with the Ardu Boy. It's pretty recognizable form factor. It looks like a Game Boy, but it's only about 3 inches tall and 1.5 to 2 inches wide, and has a 64 by 128 OLED display on there. So you get a white pixels on a black background, but you get the iconic black D-pad, up, down, left, right, and the 2 red buttons. And the other thing I love about the production Ardu Boy is it's got that great beveled acrylic. I don't know if it's acrylic, maybe it's just clear plastic, but there's this faceplate on it that makes it feel like it's in a case, but you're still just looking at the circuit board, which is pretty cool. So I'm not the only person that shares a love of this form factor. There's actually a huge community around the Arduino Boy, around the Ardu Boy. And that community has been hard at work for a little bit over a year now, developing a cartridge form factor so you can swap out games on this thing. The form factor is supposed to be really super thin, and it's got an integrated battery in there, and it's kind of like you get it, and you're supposed to either play games on it or plug it in through USB and write new games to it, or load games that you've gotten off the internet onto it, and play them that way. But this group has taken the backplate off. They've 3D printed a new backplate that has a little bit more space, and then they've come up with a specification for a right angle header and a mating socket and a housing size for these cartridges, so that you can plug a cartridge in, press the button on the cartridge, and a hack within the bootloader that they did for the original Ardu Boy will load whatever's on the cartridge. But of course, once you start to see those successes and more people get excited about it and more people come in, everyone starts riffing on everyone else's ideas, and you start to see a whole bunch of new stuff. So you see people come in and they're like, hey, I can help out with some of the design of that form factor. And then the next thing that they'll upload is 6 different takes on what the thing could look like. And you see a bunch of people soldering different things together. Oh, we can save some space here. They actually are using a chip that is running at 3.3 volts, and so they need level shifters. And so you've got people putting in a couple different designs for either using a level shifter chip or using a diode drop to make that work. And then it goes on, once they've kind of got the form factor settled, then someone's like, hey, I made a paddle controller for this. So then they're playing Breakout with
Nice.
a turn knob, with a rotary encoder. And then someone's like, that's awesome. Here's a render of what I think it would look like if you made 2 paddles, and then you could play Pong against another person. And then, a few posts down, it says, oh, hey, here, I made a dual screen. So you get a second 128 by 64 screen. I'm like, oh, that's neat. you're going to have the screen mirroring. It's not mirroring, it's expanding. And they show like a screensaver with the word Ardu Boy, bouncing off the walls, and it's going from one screen to the other. So tons of exactly what you want out of this.
That's super cool to see people getting all together and just going crazy.
Yeah, so I'd love to see the community aspect of that. That's exactly the kind of hacker stuff that, that we want to see out of people owning their stuff and saying, hey, what else can we do with this? Let's try it. Who's in? And having a lot of fun along the way.
Our next one up is a YouTuber and hacker, Tom Stanton, who's slowly becoming one of my favorite YouTubers out there. This one is Unconventional Drone Uses Gas Thrusters for Control. Let's see. So Tom has got himself a drone, and he's wondering if he can steer it around using gas jets, gas thrusters, like you would if you had a spaceship or a satellite or something like that out in space. Naturally, he's doing this, at about head height down here on the Earth. So that part of the simulation's out. But what he learns about this and how he goes about applying real engineering and science to figuring out how much thrust he can get out of these thrusters, what kind of nozzle sizes to use, all sorts of whether this is even going to work at all, is really fantastic. And while you're on Tom's YouTube channel, you should check out his trebuchet videos, because he goes through trying to figure out the physics of optimizing trebuchets. And these are absolutely fantastic and full of real world data and, measurements. And this one went faster. This one's better optimized. And I think we even covered one of his recently where he is throwing up automatic parachuting trebuchets and trying to figure out how high you can get them to go up in the air. I mean, it's this kind of geeky, nerdy, physicsy, plus some good measurement, trying to do something crazy cool that I'm really enjoying out of his videos. And this gas thruster drone is absolutely no exception.
So it's really just compressed air, right?
Yeah, so maybe I should describe the setup. He's got a drone with a big fan on it to give it lift, and he's got 3 compressed air thrusters located around the thing, and he's actually got, it sounds like they're little relay-driven nozzles opening or relay-driven valves opening and closing on these things. So one opens and it lets compressed air out of a normal 2-liter bottle, and it goes pfft. And he's trying to figure out how possible it is, if it's possible, to stabilize this thing entirely using the compressed air gas thrusters.
Yeah, it makes me think of those backpacks that the astronauts wear that have the joysticks in them, and they have thrusters so you can go untethered out in space and still maneuver around.
Yeah, it's doing exactly that, but he's trying to do this on a much smaller scale, a terrestrial scale naturally. But also, it's a lot harder, the problem he's setting himself up for. Because if you think about how slow the reaction time's going to be from a valve opening and closing, this is a solenoid valve throwing an actual physical valve open and closed to pushing the air out of there, there's got to be some horrible lag in the system. And then if you want to work out the control algorithm to make this thing work with these kind of bang, bang, on, off, noisy little clackety solenoid valves, I do not envy him that problem.
I'm pretty sure he could slap an Amazon sticker on the side of this and say gas thruster drones ready for testing on package delivery, and people would eat it up.
Exactly.
I think that's about the state of the rest of the delivery drone development right now.
Yeah, it might well be.
All right, I think we need to move on to quick hacks.
Quick hacks.
Quick
I didn't write music
hacks.
this week. Did you?
Quick hack. Quick hacks. I don't know. I can't believe no one sent us music.
Quick
We
hack.
specifically asked for it. So I'm going to start off quick hacks this week in 42 seconds or less. Here are 3 of my favorites. If you love chiptunes and I love chiptunes, you're going to love Spectrum chiptunes on an STM. This is a hack by Dieter78, where he ported some code for a General Instruments AY38910 audio synthesis chip over to a STM32L476 dev board. Now, this chip was in the ZX Spectrum, and in the video, I can't believe how great it sounds. I just put this video on loop for a while I was working, just because it's fun to listen to. This dev board is super overkill for it even, and can hold about 252 minutes of this music. It's the glory days of video game music. And if you're looking to make an old-timey but sounds awesome video game hack, use this method because we love it. Next one up is assembling a lathe from not a lot, and this is from Sec Austria's YouTube channel. This channel I was not familiar with, and you should go back and check it out because it's pretty hardcore. In this particular hack, he's making a metal lathe from scratch, and it starts off with steel tubes, like steel square tubing and some angle iron being welded together. He does use machined rails and some more modern parts, but it is a bootstrapped from the ground up, build your own parts as you go assembly, and it's great. I went back and looked 2 years ago. His very first video published on this channel was a electric toothbrush that was 2 rods that stretch out where the shaft of the toothbrush would be, and then a toothbrush head that slides along those rods, and then 1 motor with a little arm, like a piston style arm to make it go back and forth, and it's hacky goodness. You're gonna love it. Finally, on my quick hacks is 1980s plotter plays Flappy Bird, and this is an HP 7440A plotter, and it has 2 axes of motion, so it can roll the paper in and out, and it can make the pen go up and down, or in a perpendicular to the way that the paper is moving. And the first thing that it does is it plots out pipes for Flappy Bird in random places, and then as you press the button, as it does the path of the bird, and if you crash into one of the pipes, you lose control of the bird, and it draws like a line drawing explosion next to it. Really a ton of fun.
All right, my quick hacks. I'm starting off with something completely absurd, and that is Alessandro's The Pianist Octopus. You have to go look at this one. It is a kid's toy piano, and then he took, I think, about 24 servo motors and made little octopus tentacles that would play the piano. You just have to check this one out. It is the craziest way to turn a $10 crappy kid's toy into a MIDI instrument, and I just love it. The aesthetics are beautiful. The idea is ridiculous. Coming up next is creating a laser cutter from a 3D printer by Gosa Adema. This one I have really mixed feelings about. It's a very nice retrofitting of a 5-watt laser onto an ANET A8. And I like this because the ANET A8 isn't much more than a 3D printer kit. And so it's a box of things you could use to make a nice 3D printer out of. And so turning it into a laser cutter is not a horribly bad idea. The thing that gives me real concern about this is a 5-watt laser out in the open, and if you don't know exactly where that head's going to go, it could reflect on metal things, and that is definitely anything above 2 watts by me is in the put it inside a box and operate it remotely with a webcam so that you don't get it in the eye and go blind forever category. And so if you're rebuilding this one, I would definitely do that myself. On the other hand, there's a ton of helpful hints in there. You can't just run a 5-watt laser off of the fan port on your 3D printer motherboard, and so you have to work around that. There's some great tidbits in here about how you'd go about doing this. Just do yourself a favor and add a box. Heck, even a cardboard box around the thing when it's in operation so you don't catch it in the eye. Bringing up the rear, captivating ESP32 camera hack by Daniel Padilla. This one creates a captive portal which turns one of those little ESP32 cam dev boards into an online web camera. If you haven't seen the ESP32 cam boards, go look at Banggood right now. I think they're on sale. They are $7, folks. For $7, you get an ESP32 and a camera, and it's everything you need minus a little bit of software to put up a webcam on your Wi-Fi network. It's pretty darn awesome, and I think we're going to be seeing a ton of really clever CV computer vision hacks coming out of these parts because they're just so cheap and so accessible. Go get yourself one right now. If you want to see how to do captive portals right or get your feet wet with these modules in an easy way, you owe it to yourself to check out this hack.
All right, our first can't miss article this week is my pick of Lewin Day's Takata's Deadly Airbags and Engineering Omnishambles. Now, I'm pretty familiar with this, the overarching story of this, which is Takata was a manufacturer of airbags for multiple automotive manufacturers, and those airbags had failures in them that were causing them to explode more violently than they were designed to, and often throwing out shrapnel when those violent explosions happened. And it led to several deaths and many injuries. But this is a really eye-opening overview of the entire story, because Lewin goes into the actual cause of the problem and then also looks at when the investigation started, how long it lasted, and what happened along the way.
Yeah, I didn't know anything about this problem until reading his article, and I thought it was really interesting.
Yeah, so the problem with an airbag is it needs to inflate very quickly. Accidents happen so fast that you need to detect that an accident is happening and deploy the airbag before you have a chance for the driver or passenger to, lurch forward and hit their head on something within the car, be it the steering wheel or the windshield or the dashboard. And so these are very carefully designed to have just the right force and timing to do that. But over the years, the chemical compound that's used as the explosive in these bags has changed. And it seems like where Takata ran afoul on this is they went to using ammonium nitrate. It was a less expensive propellant, and it turns out in retrospect that engineers in the 90s had actually warned that this material was not a safe one to use for this, and it seems like Takata continued using it anyway.
Yeah, and there's a bunch of interesting comments in the comment section. One by someone who claims he used to work with Takata at the time. You should go read through the comment section. I would be repeating gossip if I said it. Coming from me, it's all hearsay. But absolutely go through there. The basic story is that some of the engineers working there probably knew that that was the case too, and were told to do what they did.
Yeah, that's an unfortunate thing to hear about. The failure on these turns out to be some kind of corrosion on the inflator device, and it happens especially in places that are hot and humid. And so it's difficult. It's definitely not happening on every single airbag, and it's only happening on airbags after that they've aged under certain conditions. And then I think the scope of the difficulty of this problem is mind-boggling because, okay, so you can't necessarily repeat it on every airbag of the same age, and then you don't have naturally occurring instances of it unless the cars are actually getting into accidents. So it's not like you can easily detect on every single car that there's a problem until there's actually a catastrophic failure of it on those cars. And so it took a long time for them to realize there was a problem. There was likely negligence along the way, and the company, troubleshooting that. And they did plead guilty to negligence in 2017. Ended up putting the company out of business. They had a $1 billion fine, I believe. But what happened in the course of that, it must have been 15 years. Actually, I think it was about 13 years. is the company kept making these airbags and selling them to automotive manufacturers. And so there are literally millions of these airbags out there. And being able to even have the parts to replace all those is not something that can happen right away. And so then in the recall effort, companies were forced to start triaging who would be recalled first by the type of climates that they lived in and the likelihood that there would be a failure.
Like you said, you need these airbags to inflate super quickly, almost explosively, but you don't want the thing to explode. And so they ran the air through a little nozzle, essentially, through a little reducer valve. And it was this that was corroding, right? And so it would get plugged up. The explosion would be much more of an explosion if the valve got plugged up. And that this was due to different temperature and humidity problems. And so you probably could, if you were a smart engineer, figure out which ones were likely to fail first. But that's just a horrible problem, and I would hate to be driving around with one of their airbags in my car, even if I were in a low-risk area.
Well, and that's something I saw a lot of the commenters talking about as well. You can't just take the airbag out of the car. Many cars won't start if the airbag's not there.
Yeah, it's essential safety equipment, right?
Yeah. And, the other thing is long-term stability of materials in vehicles is a super hard problem. It gets to be 35 or 40 below actual temperature here on occasion. And then if you leave it outside to sit during the summer, what do you think it gets to be in there? About 120, 130 degrees
probably
in that vehicle. And yeah, so like we have, some carpeting in one of our vehicles that is the adhesive for that carpeting has totally failed at this point. I look at it, I'm like, well, obviously, this car is years old and it's gone through all these temperature changes and like what adhesive can survive those hots and those colds and not fail at some point?
Yeah, I guess you're right. I guess it's a miracle that everything does survive as well as it does inside your car.
Yeah, so I think, you've probably heard the name before. You might have been involved in the recall and know a little bit more about it. But I think from an engineering standpoint, this gives us the ability to peer a little bit about what it was like to be on the staff of Takata during some of these investigations and the things that they were prioritizing, and gives you a little insight to the part of the problem from a manufacturer's point of view and from how do we fix a problem of this scope. So go out and read Lewin's article. I really enjoyed it this week.
My can't miss article of the week is Shorting Pins on a Raspberry Pi is a Bad Idea. PMIC Failures Under Investigation by Jonathan Bennett. And the basic problem here is that if you have a Raspberry Pi 3B+, it's got a new power management integrated circuit in it that takes care of giving the Raspberry Pi's system on a chip all of the different voltages it needs. The kind of obvious problem from the title, shorting two pins together isn't a good idea, arises because of the way the pins are arranged on the pinout on the Raspberry Pi, and that in fact has the 5-volt rail and the 3.3-volt rail pin out right next to each other. And what this means is that if you're working on a powered up Raspberry Pi 3B+, and you happen to slip, you can connect these two together. And so you send the 5 volts into the 3.3 volt pin. Jonathan wrote Raspberry Pi and got a response directly from Eben Upton himself, who said, yeah, this is totally a problem. It kills the power management chip. We know how this happens. We're working on a way to fix it. He's also heard rumors of them failing other ways and would like to figure out how that's happening. But I don't know if I put much credibility in these rumors. The reason the chip's dying is because this PMIC, the power management chip, has a bunch of buck converters in it, essentially, that are trying to create a bunch of different voltage levels simultaneously. And when you stick 5 volts on the one that's supposed to regulate itself to 3.3 volts, the little logic in that buck converter says, oh man, my voltage is way too high. I need to short that to ground. And because it's always too high, it essentially jams this little MOSFET that's inside the chip full on, and it shorts the 5-volt rail to ground through this tiny little MOSFET. someone in the comments mentioned that that's probably a safety feature to burn out this MOSFET instead of burning out your 3.3 volt device. And I guess I actually believe that. But at the end of the day, what happens is this little MOSFET gets fried, it gets crowbarred and fried, and your power management chip doesn't work anymore. And it's hard to imagine removing this thing and resoldering it, although I'm sure somebody will prove me wrong out there.
Well, so that's the interesting thing is that Jonathan actually tried to do it and couldn't get it done successfully. And I thought it was interesting. He mentioned this to Eben Upton, and the reply was, well, you can't just source that part. You should try and pull one off of a working board and putting it on this one and seeing if that fixes it. I kind of looked into this because I'm like, why can't you get that part? And Jonathan sourced it as a part number MXL7704. But if you go onto the schematic for this board on the Raspberry Pi site, they source it as XL7004. So it doesn't have the M and it has an extra 0 in it, which is kind of a question because you can see in the picture it's Jonathan's part number. And this makes me wonder if Raspberry Pi is getting these parts with special register fuses set on them at time of production, and so they get a different part number for it. And I'm not sure what the purpose of that would be. The one that comes to my mind would be secret sauce so that people can't clone Raspberry Pi 3B Plus boards.
Oh, I think it's much less sinister than that. I think they need different power domains to come up in a particular order, and the chips let you program that order. So it'll first bring up the 1.8 volt, and then it'll bring up the 3.3, and then it'll bring up the 5 volt lines or something like that.
I guess then the research point would be to take a working board and try to read those registers out. I mean, I didn't download the data sheet for this or anything, so I'm kind of just spitballing at this point.
There's some awesome comments there's some awesome discussions starting up in the comments section, and I hope that some people look into these and figure out what it is that's special about this power management chip, because it would be nice to have a commodity, a simple and easy to use fix for it. At the same time, you should be able to RMA a dead board back wherever you bought it and get another one. So I totally understand wanting to try to hot air reflow this tiny little chip out and replace it. But at the same time, if what you really want is just a new working board, talk to whoever it is you bought the board from and they'll send you a new one.
Yeah, I think we get spoiled because my understanding is chips used to be a lot easier to kill. And over the years, they've become incredibly robust. And so to have something like this happen now seems like a rarity.
Yeah, how's it even possible? I short everything to everything all the time. I go walk around in my sweater, I rub balloons on my head, and then I touch chips, and they don't die of electrostatic protection anymore. That was like the 70s. Who are you even talking to?
Yeah, use your cat as a solder mat because
exactly
nice and soft.
Yeah.
I haven't heard anyone talking about static electricity through the voltage rails as a cause of this yet.
No, I don't think so. I wonder if you could zap it. That might be interesting. I don't think there's any reason to blow up your chip, though.
My initial thought was, well, just put a bench supply onto the pins that you need. But someone mentioned it's more than just the 3.3 and the 5 volt supply, and I looked at it, and there is also a 1.8 volt rail in there. So, and then I think, as you mentioned, they're supposed to come up in a certain order in order to boot that system on a chip. And so even if you did supply all 3 voltages, somehow you still have to get the order right.
Yeah, if you hose the power supply, the thing is hosed. On the other hand, this totally isn't catastrophic, right? Because most of what matters about a Raspberry Pi is that the data on the SD card is still fine. And that isn't affected at all by this, right? You just buy a new one and plug it in and you're back where you were.
Do you think we're going to see refurbs on the secondary market?
Oh, interesting. Yeah, how much is it worth somebody's time to be reflowing new power management chips into these things? That's an awesome question.
They were $35 to start, and then you send it back, and someone has to work on it. Huh. Hard to say.
I think if you were good at that, you could do it easily for that margin. I think that's awesome. That's a great idea, Mike. It's 0.5 millimeter pitch, which is small, 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 but it's absolutely not intractable. It should be doable by someone who's much better at that sort of thing than I am.
Well, that's all the time we have for this episode of the Hackaday podcast. As always, we'd love to hear from you. You can leave a comment on the show notes by going to hackaday.com/podcast. You can email us, editor@hackaday.com. And until next week,
Keep on hacking.
hey, really, really good news for you. I cleaned my desk.
If Marie Kondo could see my desk. Anyway, I'm totally stoked to see the... I'm done with this. We're done. You do the next one. C'est la vie.